Greetings to all. Welcome back to my channel. Today we are going to see the Dust-Martin per iodine oxidation reaction. It is used to convert the alcohol to the aldehyde. Depending upon the alcohol, either it is primary or secondary, we will get the aldehyde or a ketone as a product. Let us see the reaction in detail. The reaction involves reaction of this Dust-Martin per iodine with an alcohol to give the ketone or aldehyde. Since in this starting material we are using secondary alcohol, we will get the ketone as a product. It was discovered by Daniel Benjamin Dust and James Julian Martin in 1983. So it is known as Dust-Martin per iodine oxidation. It is used to convert the primary alcohol to aldehyde and secondary alcohol to ketone. Let us see the mechanism in detail. Reaction mechanism involves three steps. The first step is the complex formation between the alcohol and the DMP. The second step is the hydrolyzed transfer, and the last step is the rearrangement. So in the first step, there is the attack of an alcohol oxygen on the DMP molecule to generate the cyclic intermediate. This is a complex. In the second step, the conjugate base, that is acetate ion, abstracts the proton to generate the carbonyl bond between the carbon and the oxygen. In this reaction, the bond between iodine and oxygen is cleaved to generate the byproduct. So in the last step, we get the acetic acid byproduct of DMP and our compound as the product. This is our compound. So when we use the primary alcohol, we end up with the aldehyde, and when we use the secondary alcohol, we end up with the ketone. This is one of the example I have shown where the secondary alcohol is converted to its ketone derivative using DMP reaction. So puts little bit effort over here. This is the protection of diol. So this is a highly reactive species. So harsh condition would cleave the bond between the two oxygen to generate the impurities. So DMP oxidation is used to convert the highly specific, and it is much less vigorous than the other oxidizing agent. Let us see the synthesis of DMP. The 2-iodobenzoic acid is reacted with an ozone to convert the 1-hydroxy 1,2-ben-iodoxal 1-oxide, which is reacted with an acetic anhydride in presence of paratoluene sulfonic acid to generate the DMP. There are many advantages of using DMP. The first one is the mildness. It is suitable for the sensitive substrate that might be degraded by the harsher oxidant. It is highly selective reagent. It doesn't have any effect on the other functional group. Efficacy. So short reaction time and generally yields are high, and the reaction condition are easily work up, and it is simple purification procedure is required in DMP reaction. Workup generally is done with the quenching the reaction mixture with the help of saturated bicarbonate or saturated carbonate solution to remove the acid impurity formed during the reaction. But there are some limitations in the DMP. The first one is the cost. The DMP is relatively expensive than other oxidizing agents. Safety is one of the concerns. In some of the storage conditions, the DMP can be explosive in nature, and thus it has hazardous environmental impact. While using the chromium reagent, as we have seen, it is highly toxic in nature. Still, DMP generates the iodine, which is also an hazardous reagent liberated during the DMP reaction. Hope you like my video, guys. Please share and subscribe.